So today, like I've been talking about, we're going to be doing science experiments, but they're going to be Easter based. So basically what that means is we're going to do experiments, but they're going to be with Easter themed items like Peeps and eggs. So the first thing that I wanted to do is, I know you can see all the little bowls right here, and basically what we're doing is we're seeing how different liquids dissolve Peeps. So the different waters, or the different liquids we have are regular water. Mother, would you like to zoom in? Let's go, Squiggle. We've got regular water. We've got salt water, vinegar, milk, lemon juice, and soda. So what we're trying to see is which liquid dissolves the Peeps faster. So to go ahead and prepare for this, I started last night around 8:30, 9 o'clock. I went ahead and made all my little bowls. All I did was put in some of that liquid into a bowl and then drop a Peep in, put them all in at the same time. And then I just left them sitting on the counter, and we moved them out here about 20 minutes ago just so we could get ready for the video. But they've been sitting like this since. I haven't touched them, haven't done anything to them. So we're gonna go ahead and take them out and see what the differences in the Peeps are. So all you need for this obviously is the bowls, the Peeps, and the different liquids. So we're going to bring them over here. I'm going to take them out one at a time, and I'm going to set them on their designated little spot. Do you want to come around this way so you can read it? So the first one I took out is the lemon juice. Look at the bottom of that Peep. It's all bubbled. I don't know if you can see the bubbles, but the entire bottom is white with foam, and it's covered in little bubbles. So I'm gonna put him face down so you can see. And if you look, the color was completely taken off of it as well. Next, I'm gonna take out the soda. The soda I used was Cherry 7-Up because I knew if I used Dr. Pepper, we would all be in trouble. So it's red on the bottom. And it looks kind of orange because it mixed with that yellow, and then it's full of bubbles. Ah, ew. Next is the milk. So that completely took off the color from that one, and it just looks like a regular marshmallow. Ew. Next one is the vinegar. That like dissolved the bottom of the Peep. Like it's supposed to obviously be even all the way down, and like the ears are caved in. A little bit of the bottom's rounded out. The poor little head's going away. And it's completely void of color. Next is the salt water. Ew, look at his little ear. And the regular water. So the regular water is basically your base example. This is just what we're going to go off of, and then the differences between the regular water to the other types of liquids that can be used. So when it comes to the Peeps dissolving, it depends on the type of liquid, like I said. So the differences depends on the level of acidity within the liquids that you place the Peeps in. The reason why Peeps dissolve when you place them in water is the ingredients within Peeps are water soluble, which means that they dissolve in water. The only ingredients that, like the main ingredients in Peeps, are sugar, water, and gelatin. All three of which, one of them being water, are highly dissolvable into water. So depending on what liquid you put it in determines the amount of dissolving that it goes through. And the liquids with higher acidity break down both the water within the Peeps and the sugar faster than the items with a lower acidity rate, or a higher. So, my Peep flipped over. So, water, like I said, is your baseline acidity. That is a neutral. So, you've got your bases and your acids, it's a 7. Water is dead in the middle. As you go down into higher acidity, which is actually a lower number, you get literally just about everything else on here. The next highest acidity would be the milk. It's at about a 6.5. Then you jump to the lemon juice, believe it or not, is only a 3. Soda is a 2.3 to a 3.1, and vinegar is a 2.4. Now looking at these, and this is basically just the water with salt added in it, so it really doesn't change much of its acidity. But looking at these, you can see that some of them kind of, like the water kind of looks the same. All it is, it's a little more bubbly, it took off the color, but it's generally got the same shape. The salt water too, it kind of, his ear broke a little bit, but he's generally the same shape. He's a little bit squishier than the water, the regular water. And then you go down to the milk, and he's kind of the same. He's missing his, he's a little pink because he blew over into the soda, but he's kind of the same. He's got less color than the others, and he's a little bit more squishy, but he's relatively similar. Then you go over into the soda and the lemon juice. They're both void of the regular yellow color, and they're starting to, it kind of looks like they melted because of how much the acidity has taken off of the sugar and the gelatin within it. So like, look at this one. His poor ears look all melted, but it actually dissolved into the liquid in the bowls that we have over there. So we're basically missing parts of our peep. And the vinegar with the highest acidity is actually the worst. All of the edges are rounded out. It looks like we kind of shaved him down. He's missing a whole bunch. He's completely void of color. And that is because he's got a higher acidity rate. So the way to do this at home is really simple. You just have a bunch of different small bowls. You have your thing of peeps, and you've got all your different liquids. It doesn't matter what liquids you use. I would recommend always having water, just so you have your base to go off of. And then just any other liquids you can see or you have in the kitchen, you can use those, put them in different bowls, and throw your peeps in there. And just see how different the peeps come out from each other when you time them. If you have them put away for longer, like if you leave them over 24 hours, maybe 2 days, you can see greater effects to your peeps. This was only about maybe 16 hours, and it already did this much. So leaving it, so let's say 24 to 36 hours, and your differences are going to be even greater, and you'll be able to see the bigger differences in the liquid to acid, or how it eats away and dissolves your peeps. So we're not the only thing that eats peeps. The different liquids apparently eat peeps. But yeah, that's really it for that. Which one did you think was going to eat away at the peep the most? Did you have a guess? But the vinegar peep definitely got the most eaten out of it. He looks sad, even on the front. He's all fallen over. And my fingers are sticky. Okay. So the next project I have, or the next experiment I have, is basically kind of similar, but instead of doing the differences in the liquids and how the different liquids eat away at the peep, instead we're going to focus on heat. How does heat affect how does heat affect peeps? Do you think, okay, so what we're going to do is we've got 2 different peeps, came from the same package. One we put in the freezer last night, and one we're going to put in the microwave in just a few minutes. So what peep do you think, what do you think is going to happen to the 2 different peeps? Do you think one of them's going to get bigger? If so, which one? So let's go and see what our frozen peep looks like. Follow me, mother. Mikey's eating something. You coming? He's behind you. So here's our frozen peep. He looks kind of the same. Let me pull out a regular peep so you can see. So here's your regular peep, and this is your frozen peep. So it's hard to tell, but the frozen peep is just a little bit smaller than your regular peep. And obviously this one's more squishy because it's not frozen. So if we take, excuse me, frozen peep. If we take our regular peep and we put him in the microwave, see what he does. Now we're not gonna leave him in there for a full minute. We're just gonna let him sit there. So what do you think is gonna happen to our heated up peep? Look. Look what happened to our peep.
Sorry, crazy camera.
So here's our heated peep, and look, he already shrunk. He got about this big, and now he's shrunk back down to not even a normal size. He's still pretty poofy, but that's because when you heat up the molecules within a peep, like I said earlier, peeps are made up of water, sugar, and gelatin. And when you heat them up, the molecules within the peep start to shake and they get real hyped up. They love the heat, so they start flying everywhere. The heat makes them dance, basically. So they dance everywhere. They're in that microwave. They're running around, and the peep starts to swell. And then as soon as you take it out of the microwave, there's no more heat, and the molecules get sad and they come back together. And although they don't go back to their normal shape because they were flying around everywhere, they are definitely not the same peep, but they were happy peeps. The little happy peep molecules, just for a little bit. While the peeps that got put in the freezer are very sad. They got very cold, and the molecules had to get nice and tight to each other so that they could try to stay a bit warmer. And everything got smushed, so it just got a little bit smaller than our big mushy peep that is just laying flat and sad. And he was happy for a few seconds, and he got to dance, and his little peep molecules got to go everywhere and expand, but now they're stuck. Back to normal peep. Well, hello, Mikey. Come on, Mikey. Oh, hi, Boo-Boo. Mikey. Boo-Boo. Okay. We have lost one of our assistants. Bella has decided to go inside. I should have prepared with a napkin. My fingers are sticky. All right. So to do that experiment at home, obviously all you need is peeps, a little plate that you don't mind putting in the microwave, a microwave and a freezer, and you just get to see the difference between a frozen peep, a regular peep, and a heated up peep. And like I said, the reason why the peeps change size is the temperature at which the molecules are held depends on how the molecules move. So the hotter a molecule, the item gets full of molecules, the more the molecules move around and dance, and the colder it gets, the more the molecules get tighter and stick together to try to stay warm. All right, so that is our 2 peep experiments. Now let's do this one. For this experiment, all you're gonna need is 3 glasses of water, one of them full, well 2 of them full, one of them halfway full, and you're gonna fill one of the glasses of water with salt. And when I say fill it with salt, I mean put a lot of salt in there. And I already did this, but I'm going to show you a little bit more. We're going to put a little bit more salt. We're going to mix it up. Okay, and then you're going to need an egg. And all we're going to do is we're going to test buoyancy in eggs, which buoyancy just means, does it float or does it sink? So if I put this egg, this is the regular water. If I put this egg in the glass of regular water, what do you think it's going to do? Do you think it's going to sink or do you think it's going to float? This is a raw egg. Well, let's see. So when you put a raw egg in a glass of water, it sinks. So let's get our egg back. And the reason why it sinks is because the egg is denser than the water. It's heavier than the water, so it's going to sink to the bottom of the water glass. Now, what about the glass of water we put salt in? Do you think the salt's going to make a difference on if the egg sinks or not? Now, remember, in the regular glass of water, the egg sunk. Do you think it's going to sink in the glass with water and salt, or do you think it's going to float? Let's see. So by adding salt to the water, you make the water denser than the egg. You make it heavier than the egg. So the egg floats on the top. Even if you poke it down a little bit, it's going to come back because the egg is now less dense than the water. The egg is less heavy, So the water and all the salt in it basically holds that egg up to the top so that it floats on the surface of your water. Now what if, so this is a half glass full of water. What if we put half regular water and half salt water? What do you think would happen? Do you think the egg is gonna sink? Do you think it's gonna float? Well, let's see. So this is, like I said, regular water. We're gonna fill it with salt. Wasting a lot of salt. Put that in there as best as you can. Salt does not dissolve into water, so I mean it's not all gonna go away, but it does help make the water, like I said, more dense. So it makes the water heavier because there's more molecules in it to hold it. So let's throw that egg in there. See if it's ready. Okay, needs a little bit more salt. So like I said, we're gonna waste a lot of salt today. Don't even worry about it.
Flies like peas.
Ew. There's a tornado in there. Okay, so there's our floating egg and our cup full of salt water. Now, like I said, what do you think is going to happen when we add regular water into our salt water with our floating egg? Let's see. Now we're gonna add it in, but we're gonna be very gentle not to disturb the rest of the water. Now look at that. So now it's not sinking, but it's not floating because you've got the salt water holding the egg up and you've got the regular water trying to weigh it down. Because it's heavier than the regular water, remember? But it's lighter than the salt water. So it's stuck in the middle between, am I heavy? Am I light? Well, it depends on the water that you're in. In regular water, it's heavy. In dense salt water, it's light. So it's stuck in the middle. So it's like when you float in water, you're less dense than the water. There's a whole other reason for that, but. And there you go, there's that project. Now the very last one we're gonna do, you have to do with the parent. You should generally do all your science experiments with parents anyway, but this one in particular, you have to do it with the parent because it involves fire. Now we're not gonna be sticking our fingers in fire and we're not gonna be doing anything weird, but what we're gonna do is we're gonna take a glass jar with the bottleneck. So we found a Starbucks glass bottle, because it's gotta be glass, and the Starbucks one was the only one that would hold the egg. So what you're gonna do is have a boiled egg, not raw, boiled, and you're gonna set it so it sits in the top. If you force it, it'll probably go through, but as of right now, it just sits in the top. So what we're gonna do, we've got our boiled egg and we've got our glass. We're going to take a scrap piece of paper and we are going to set it on fire, which is why you need an adult. I'm going to use my adult. Here, adult. Set that on fire, adult. Okay, and what you're gonna do is your adult is going to set the match on fire, or set the piece of paper on fire, and drop it into your glass jar. Not the whole match. Set the egg on top and watch your egg. Look at that. Now, how does that make any sense if that egg was sitting on the top of the glass bottle? And you saw it sitting, it wasn't going in. So what happened to the air in the jar and the egg for the egg to suddenly get sucked into that jar? So basically what happened was, when you light the piece of paper and you put that fire in the bottle, putting the egg on top blocks the air from coming in and out from your bottle, and it lights up the air inside the glass jar, and it excites all the molecules, and the molecules start shaking around everywhere because they like the heat. Remember, with the peeps, they love the heat. So the air molecules are flying everywhere. And if you notice, it was probably hard to see, but the egg up top, as soon as you set it on, it starts to shake because the air inside the bottle is rushing, and it's trying to get all of your it's trying to suck in all the air it can, so it's shaking the egg, and the air is getting sucked in around the egg. So when the air inside runs out, the pressure inside the jar, the air pressure goes down because the fire burned out all the oxygen in it, and it sucks the egg inside because the air inside the bottle is less air pressure than the air outside. So the outside air pushes your bottle in, or pushes your egg inside the bottle. So as the flame goes out, the bottle loses air, and it causes the internal pressure to be less than the outside pressure, which causes the egg to get pushed inside the bottle. So basically, that flame makes the molecules all happy. They dance. They try to even out, because anytime you have pressure, they try to even each other out. The pressure inside the bottle wants to be the same as the outside pressure outside the bottle. Everything wants to be balanced. Everything in nature wants to be balanced. So when you lower the air pressure inside, because that flame is burning the air inside the bottle, the egg starts shaking because the bottle wants the air back to normal. The air wants to go back to normal, so it's sucking that outside air in. And when it's not sucking in enough air, and the pressures go uneven, the outside pressure being more than the inside pressure, it sucks that raw or that boiled egg down into your glass jar because the pressures are finally balancing out, and that egg was just in the way, so it got that out the way, and now the airs are back to even again. That was a mouthful, but that honestly is probably one of my favorite experiments. The rest of them are cool, but I think that one is my favorite because you can see the difference in air pressures because of the drastic movement that the egg makes. It didn't just slip through. The air pressures outside and inside the bottle made that egg change placements. It wasn't just it fell through, because if it was just going to fall through, we would have seen it fall through when we set the egg on top. Hi, Mikey. Instead, the pressures changed the position of that egg. All right. That is all I have for you today. That was 4 Easter science experiments that I hope you guys had fun with. I hope to be doing experiments probably daily. If I don't have time for daily, then every other day or something. But I'm recording this one too, so that way if you didn't get to see it live, it can still be posted and you can see. I'm going to edit it a little bit so you can see it better. But that was 4 experiments. You can definitely do those experiments at home. All of the materials are easy to find except for that glass bottle. It literally took us from last night when we put the peeps in the different liquids. From last night to now, we found this literally like an hour ago because we couldn't find a bottle that would hold the egg in the top that wasn't too big or too small. Because if it's too small, there's not going to be enough pressure to shake the egg through. The egg's just going to break. But so don't be getting your beer bottles. We thought about that. The beer bottle's too small. You have to get this is honestly probably one of the only bottles you're going to find without having to go buy one that is not going to benefit you for more than science. But yeah, so all of the stuff you have is basically in the house, so you don't need to go out and buy anything unless you don't have a Starbucks bottle. That's fine. Just see if you can find something else. We were going to use my dad's, I think it's called the decanter, but we didn't want to not be able to get the egg out and then him not be able to use it anymore. But yeah, so you can do all these at home. They're not hard. The good thing about it is if your parents run it or anything, then you can set up a little notebook and they can do the actual scientific they can do the actual scientific process in their notebook depending on how old they are. All you do is have them write down the materials, have them write the problem, like what's going on with the project. So why won't the egg fall into the glass or something like that, or what peep I'm not gonna blow stuff up, or what peep dissolves in what liquid the best. And then you have your hypothesis, which is just their guess. Guess which peep you think is going to dissolve the most. Is it going to dissolve more in regular water? Maybe the soda? That would be your hypothesis. And then you write out your steps, have them write down their steps. Even if you don't want to do that, you don't have to. This is just things to kind of stimulate thinking. And then at the end, have them think about why what happened. If you need to look it up, like some of these I had to look up, like I knew the general reasons, like, but I couldn't explain it to you. So if you want to look it up, that's completely fine. And just have it broken down in a way that they can understand it. That the egg got sucked into the bottle because the air inside the bottle was hot and they were dancing, and then when it cooled down they didn't know what to do, so they pulled that egg in there so they could get more air in there. That's all you got to do, is break it down in a way that they can understand it. But doing stuff like this makes it fun. It's not just sitting down with an open book. What does pressure mean? What is the difference in pressure? It's seeing it for yourself. My peeps fell. It's seeing it for yourself and getting to do it yourself. You are making differences in air pressure. You are making different solutions dissolve peeps. Like it's a whole different thing to be able to do it yourself than to just read about it. So definitely try to do more science experiments. I'll try to keep up so you can see and you can participate with the experiments with us. I'm going to do past this. I could only do these ones because and only like one active experiment because a lot of the Easter based ones were time consuming, so I had to do them last night, like putting the peeps in the solutions and then showing y'all the results today. But the ones I'm going to be doing further are going to be active science experiments that they can keep up with and they can do while I do it, and I'll explain to them how to do it and stuff like that. So I'll definitely be posting different materials you'll need for future science experiments and stuff like that. So I hope you're excited. I hope you had fun watching the science experiments and you can have some Easter fun. Do not be around too many people. We're still in shelter in place, but have fun for your Easter. Bye. Now, how do you turn this off?